Okay, so we've got Jimmy back here. So Jimmy is going to take this path to school. He's going to jog, and he's gonna go 25 minutes to get to school. What is his average speed and velocity? We've got our speed divided, there's a distance divided by time. So in this case, we just care, speed is a scalar unit, so his distance, we just care about the total amount. So we got 120 plus 50 plus 50 plus 60 plus another 150. We'll just add all of those up. Okay, we divide that by our time, which in this case we could just do 25, and we could say our distance was meters per minute. But we like to use seconds for, and we talked about in our unit presentations. Um, all we did was we converted our minutes right here. This 25 times 60. That's our unit conversion to put our minutes in 2 seconds. You add all those up, you times those together, and then divide them, and it comes out to be 0.28 meters per second. So Jimmy's speed was 0.28 meters per second. That's going to be a little different than his velocity. Because remember, velocity takes into account displacement. And if we can just look right here, we know we're going forward and then backwards. So our displacement isn't going to be exactly there. In fact, it's going to be a straight line from here to here. Okay. So what we've got to do is we've got to remember when we have a weird route, we got to make ourselves a triangle. So we're going to add up all the left and right. So in this case, we're going to go 120. We're going to minus off 50 right there. And we're going to add another 150 to give us 220. Then we add up all of the up and down. So in this case, we're just going down for both of them. So it's 50 plus 60, which gives us 110 meters. From there, we can build our triangle. Okay, so we've got 220 there. We're going down 110. We put in our arrow here. We now just use the Pythagorean theorem to get ourselves this distance. 220 squared plus 110 squared. We square root that. We come out to 246 meters. Now that is our total displacement. Okay, it's not the same as this one up here. And so because there's a different displacement, we've now got to plug that into here. Our time will be the same. That doesn't change. So as you can see, 246 divided by our time, which we just converted it over to seconds again, and it comes out to be 0.164 meters per second. That is our average velocity. Notice they are not the same. The velocity is a little lower, and part of that is because we've gone backwards. We went backwards at one point in time, and so our route took that into account, but our velocity does not take that into account from where we ended.